Hello, this is the answer key for the second worksheet on scientific notation. So scientific notation is a way to write a very large number or small number by expressing it as a coefficient, such as 6.022, and then an exponent, let's say times 10 to the 23. This is Avogadro's number. This is the coefficient, where this must be between 1 and 9.99, and then this is the exponent. All right, so let's do some problems. So the first set of problems asks to convert each of the following numbers in scientific notation, each of the following numbers to scientific notation with the correct number of significant figures. All right, so we have 168.2. So this one, we move it 1, 2. Whenever you move towards the left, that means that the exponent will be positive. So this is 1.682 times 10 to the 2. The second one, 0.000890, we move it 1, 2, 3. If I just moved it 3, that means it would be 0.89. I don't want that. So I move it 4, that gets me 8.90. I moved it 4, so it's 10 to the negative 4. I moved it towards the right, so that's negative. So 0.034, I move it 1. I move it 2, so that's 3.4 times 10 to the negative 2. I moved it to the right. Here, 289 million, I move it 1, 2, 3, 4, 5, 6, 7, 8 times. So that'll get me 2.89. I moved it towards the left, so that's times 10 to the 8th. All right, 3,409.0. 1, 2, 3 times I move it. So that means 3.409. I keep this 0 because it is significant here, so it must be significant here. And so because I moved it 3 times and I moved it to the left, that's 3.4090 times 10 to the 3. 1000.00, I move it 1, 2, 3 spots. So 1 point, all these zeros are significant because they're trailing and there's a period here, so I keep them all. And I moved it 3 spots, so that's times 10 to the 3. All right. This number here, it's really small, so I move it 1, 2, 3, 4, 5, 6, 7 spots. So 5.61 times 10. Remember, I moved it 7 spots, so negative 7. And then finally, 547.9. I move it 1 spot, 2 spots. So that's 5.479 times 10 to the 2. All right, let's go on. All right, so now this one wants to go the opposite way, from scientific notation to decimal form. All right, so here, 4.595 times 10 to the 2. Here, if it's positive, I move this decimal place to the left, to the right, sorry. That I'm basically making this number here larger. So that would be 459.5. I messed up. It's 0.5. Here, 8.90 times 10 to the negative 3. I would move it 1, 2, 3 spots. So I'd put a 0 here, 0 here. So I'd get 0.00890. I have 3.2 times 10 to the 1. This is bigger. This is positive, so I move this to the right. So that would be 32. 3.2 times 10 to the 2. I move it 1 spot and then 2 spots. Notice I have to add this 0 here to make that work. So 320. 3.2 times 10 to the 3. I'm going to move it 1, 2, and 3 spots. So I'd have to add a 0 here and a 0 here. So that's 3,200. Notice this has 2 sig figs. In C, this has 2 sig figs, so this has 2 sig figs, 2 sig figs here in D, so my answer has 2 sig figs. Here in E, 2 sig figs, so my answer has 2 sig figs. 3.2 times 10 to the negative 3, now it's negative, so I move this to make this number smaller. So 1, 2, 3 spots, so I put a 0 here, a 0 here, and I need to put a 0 point there. So 0.0032. 5.30 times 10 to the negative 4. Let's just write that down here so we can show it well. I move it 1 spot, 2 spot, 3 spot, 4 spot. So zeros go here. My period ends up here, and so it's 0.000530. And then finally 6.34 times 10 to the 8th. So I'm going to move this decimal spot 8 spots. So 1 spot, 2 spot, 3 spot, 4 spots, 5 spots, 6 spots, 7 spots, 8 spots. So this would be 6, 3, 4, 1, 2, 3, 4, 5, 6. That's why we use scientific notation, because this number right here is easier to write and work with than this number right here. Now we're going to look at ordering numbers. All right, so sometimes we want to know what's the largest number, what's the smallest number. We might need this for an experiment or who knows what. So let's say we have this problem. We have these 5 numbers and we want to order them from smallest to biggest. Now the key thing is that notice that some of these are in scientific notation and these 2 aren't. So we need to convert them all to scientific notation. Or you can convert them all to decimal form. Okay, that means something like 30,200. Seeing that 3 are in scientific notation, I'm going to change these 2 to scientific notation. All right, so we have 3,200. To change that to scientific notation, I would move it 1, 2, 3 spots. So that means this is 3.200. I moved it 3 spots, so that's times 10 to the 3. 0.029. I move it 1, 2, 3 spots again. Sorry, not 3 spots, actually only 2 spots, 1 and 2 to get me 2.9. Remember, my goal is always to have a number between 1 and 9.99. So I had to move it 2 spots. And seeing that I had to move it towards the right, that's times 10 to the negative 2. So now I have these 5 numbers. And so now I look first based on the coefficient. And if I look at the coefficient, I have 2 that are times 10 to the 3. So those are my 2 largest numbers. So then I look at coefficient. So 5.38 is bigger than 3.2. That's the biggest. Then I have 3.200 times 10 to the 3, or 3,200. That's what we started with. Now, if I look at it, now I have 3, I have negative 2 here, I have negative 3 here, and I have negative 2 here. Oh, both these are negative 2, right, here and here. And notice they're both the same number. So once we converted from decimal or from scientific notation to the decimal form, or from decimal form to scientific notation, these had ended up being the same, right? So this was a little bit of a trick question. These 2 numbers are the same. And then the smallest one is the one that is to the negative 3. All right, let's do some more. Now 3b, here, they're all in scientific notation. So I just look, okay, so negative 9, negative 9, negative 1, and negative 8. So the negative 9s are the smallest. 3.8 is smaller than 7.77, so that's the smallest number. Then -8. And then finally 1.62 times 10 to the -1. If they're all in scientific notation, you don't have to convert, just use those. All right, see, again, we have 3 in scientific notation, 1 not. So I need to convert this to scientific notation. So 2.80 times 10 to the 2. All right, so I have 2 that are 10 to the 2 and 2 that are 10 to the 3. So that means the 10 to the 2 are the smaller. And 2.8 is smaller than 2.9. Then I have these 2 that are times 10 to the 3. And I look, all right, 1.49 is smaller than 4.92. Notice it goes by coefficient, or sorry, by exponent first, and then coefficient, right? 1.49 is not the smallest because of this 10 to the 3. 3D, here we have 3 in decimal form and 1 without. So 1.49 times 10 to the 3. So I'm going to convert that one to decimal form. So that would be 1.49 times 10 to the 3. So I would move this 1, 2, 3 spots. So this is equal to 1,490. So of these 4 numbers, 1.29 is the smallest, then 825, then 1490, and then finally 2979. I could have changed them all to scientific notation, but it's easier just to change 1 than to change 3. Finally, same thing for E. Notice here only 1's decimal form, so I can change this to 9.9 times 10 to the 1. I have 10 to the -1s. These are the smallest. 1.03 is therefore my smallest. And then I get 8.23 times 10 to the 1. And then finally 9.9 times 10 to the 1, or 99. Number 4. Here we're looking at the number of significant figures in scientific notation, and then we're doing some rounding. So significant figures, we're only looking at the coefficient, right, in front of the number. So here in 6.760, all these are significant, so that's 4. If I want to round this to 3, I would keep the 6, keep the 7, keep the 6. So it's 6.67 times 10 to the 3. If I rounded to 2, I would keep the 6, keep that 7, but then based on the 6, this 7 becomes an 8. So it's 6.8 times 10 to the 3. Notice that the exponent, the times 10, does not change. It's always times 10 to the 10 to the 3. And so in problem 2, I know already my exponent's not going to change. It always remains the same when we have to round. All right, so let's look at this. So in B, I have 1.6096 times 10 to the -3. Significant, significant. This is a captive 0. Significant, significant. So it has 5. So to go to 4, I'm going to keep the 1, keep the 6, keep the 0, keep the 9. Round it based on this 6, so it rounds up. So it would be 1.6. If I round up this 9, it becomes a 1, 0. So 1.610 times 10 to the -3. If I round it to 3 sig figs, I'm going to keep the 160, round up based on the 9, so it's 1.61. If I rounded 2 sig figs, the 1 and the 6 stay, and I round down, so it's 1.6 times 10 to the -3. All right, C, if I look at this one, I have 6.022 times 10 to the 23. This is Avogadro's number. that you use or you will use. This has 4 sig figs. I'm only looking at that coefficient. Rounding to 3, I keep the 6, keep the 0, keep the 2. I round down based on that. So 6.02 times 10 to the 23. If I round it to 2, I would again keep the 6, keep the 0, round down based on that 2. Here in D, we have 9.0000 times 10 to the 8th. These 4 zeros are all significant. Why? Because of this decimal place. So there are 5 sig figs here. And so if I want to round to 4, I keep the 9 and 3 of those zeros. If I rounded to 3 sig figs, I keep the 9 in the first 2 zeros. And if I just rounded 2, I would keep the 9 and the first 0. Moving on to E, here I have 3.810. All 4 of those are significant. If I round to 3, I keep the 3, keep the 8, keep the 1. My exponent doesn't change. If I round to 2, the 3 and the 8 remain constant. And so there we go. Scientific notation calculations. Here we're going to use your calculator. Now in the video we went through the steps, but use your calculator and make sure you do it correctly. So 345 divided by 1 times 10 to the negative 10 to the 9th. Notice I'm taking 345 and dividing by a really large number, so that's why I get a small number. 6.28 times 10 to the 6 times 3.4 times 10 to the 3. I get 2.1 times 10 to the 10. Again, watch that video. Make sure you're doing the calculations right. If you're not on your calculator, go ahead and talk to your instructor. So 1.72 times 10 to the 6th plus 2.41 times 10 to the 5th. I get 3.681 times 10 to the 6th. Right? Now, because I am using, I'm doing addition, right? We go ahead and we keep the 2 decimal places, so this becomes 3.7 times 10 to the 6th. 550 divided by 1 times 10 to the 9th, I get 5.5 times 10 to the negative 7. 2.28 times 10 to the negative 7 times 1 times 10 to the 9th, I get 228. This has 3 sig figs, this has 3 sig figs, so my answer has 3 sig figs. Then 4.8 times 10 to the negative 3 plus 2.2 times 10 to the negative, or plus 2.2 times 10 to the negative 2. I get 0.0268. I'm going to go ahead and convert this to 0.027. If I wanted to do this in scientific notation, this would be 2.7 times 10 to the negative 2. Both of these are the right answer. All right, so that is the worksheet. Go back to that video if you need help or talk to your instructor. Bye-bye.